So welcome everybody to this week's Gardener review meeting. We are looking at the 1.46 release today and have the following topics. Dominic will start with the new feature for the VPN, which is about the watchdog. Then we have Andrea with the new HasIgnoredManagedResources constraints for shoots. Next up is Lucas with the NFTables mode support in the Calico extension. And finally, Tim will give us an overview of the Gardener Landscape Kit, which was proposed with GAP 49. All right, then Dominic, please get started with the VPN Watchdog.
Okay, hello, good morning. Let me just start the sharing. I hope you can see my screen now. Yeah. Let me just, I have a couple slides. Okay. So, HAVPN Watchdog, what is this about? So the main idea is to observe the quality of the connection we have from the shoot to the seed. We currently observe if there is a connection at all, which is the readiness check that we have established a couple of releases ago. But the problem with that is that it doesn't check the quality of the connection, only checks if there is a connection to the seed. And if so, then we will just start sending traffic. But we have seen in the wild that even though you might have a running connection, the quality of this connection can deteriorate over time. And the problem is that OpenVPN itself doesn't really offer any solution to reestablishing a connection, save for 0 packets for like half a minute or so. The problem is 0 packets you never reach, even if your connection is bad, even if your webhooks time out or whatever, you will still have like a couple of bytes still going over this wire, even though you experience this as an outage. So therefore, we added a new logic into the VPN shoot, which we call the watchdog. It's basically observing the quality of the connection and will trigger a restart if it detects a bad connection. So there is some limitation to this. So first of all, if it only changes on the shoot side, so the seed side is unchanged right now, and it's set at a rather conservative value right now, which is a failure rate of 50%. We started with this conservative value because we didn't want to accidentally cause restarts left and right, and we will adjust this value over time as we see this going into production. So as a quick recap, we have basically 2 components in the HAVPN that are connected. On the seed side, we have the path controller. The path controller basically keeps pinging the shoot side every 2 seconds to see if any of the VPN shoots became unhealthy, and it then makes a switch in the route table of the Kube API server to select a new VPN shoot for sending the traffic. It also sends its own IP address, so the Kube API server IP address in a UDP packet. That's because in HAVPN, Kube API server is a deployment, so it has an arbitrarily number of replicas that may scale up and down. So the VPN shoot doesn't know in advance of these IP addresses. So it reads the UDP packet and establishes a back route back to the Kube API server. And this is where we actually hook into this watchdog, because we expect these UDP packets to arrive at the tunnel controller on the right-hand side in the shoot every 2 seconds. And we have a timeout of twice that, so 4 seconds. If we don't get anything from the seed side, we deem this as a timeout. And then we basically record these timeouts in the watchdog. The watchdog has a window that wraps around, and if that window detects more than, right now, 50% failure rate, it will trigger a hang-up signal by connecting to the local OpenVPN process. That's a management port that was opened in localhost. And this will trigger OpenVPN to transparently restart the connection. OpenVPN, the process itself, does not restart. It's only the TCP connection that actually gets restarted. So the Watchdog window works this way. It has a certain size, and it will record every time it gets a UDP packet or does run into a timeout. It will record OK or not OK. And depending on the threshold that we set, right now it's set at 10, so 50%. Over this time period of 20 reads, basically, it decides, okay, this connection has become unstable, or I need to trigger a restart, or this connection is still somewhat fine. So if the restart is triggered, the window will reset, so it will be cleared. And then we will have another thing called a cooldown, which basically is here to make sure that we don't run into sort of restart loops, because once you restart the connection, obviously the connection gets torn down and has to reestablish, which may take some time. And during that time, we will also try to read new UDP packets, which won't work immediately, of course. And to avoid like triggering another restart right away, we have a cooldown period where we don't do anything, where we also don't record any errors. Yeah, I will just give you a short demo, and then this will be over. Okay, so on the top right side here, I have the shoot. The VPN shoot 0 will be the one we will trigger. And on the lower right side, I have the seed side, where we see the VPN seed server. Let me just bring up the logs here, just to be sure. So if the trigger gets called, if the watchdog gets called, we should see a log statement here in the VPN seed server telling us about a new connection from a VPN client. On the shoot side, you have this tunnel controller component that basically keeps reading these UDP packets, and the watchdog will then basically write log statements here if it triggers or if there's a failed UDP packet. So I'm on the lower left, I'm logged into the node where this VPN shoot 0 is running, and now let's pretend there's some trouble in paradise by just issuing a drop of all these UDP packets that go into this into the bound device of the VPN shoot. Okay, so on the right side, you see now there's this reading from UDP failed error message. This was here before, but there was nothing being done from it. But now we have the watchdog on top of it, just recording these errors. And by the time it should reach at the threshold of 10 failed attempts, it should trigger a restart and the cooldown period. Let's give it a few more seconds. Okay, now it has triggered the restart. You see in the down right side, a new VPN client has connected to this VPN server. And on the right above side, you see the cooldown is now triggered. So even though we are no longer still receiving these UDP packets, we don't do any more restarts. Let me just undo this this IP tables rule here to make it fine again. And now this guy should stop. And yeah, the connection has been re-established. It's the same VPN shoot 0 that has been connected to this VPN server. Hopefully, the connection is now more stable. Yep, and that's it. Any questions?
Apparently not.
Back to you.
Yep, thanks, Dominic. And next up is Andrea with the HasIgnoredManagedResources constraint for the shoot clusters.
Yes, thank you. So I'll start sharing. Yes, I don't have a presentation, but since my topic is rather short and not so technically involved, I just decided to present a bit show the pull request and then a small demo. So the reason for this topic is that in teams with lots of let's say support SRE colleagues that work on different time zones, it's usually possible that sometimes during customer ticket, some managed resources need to be ignored and manual workarounds have to be done to solve the customer issue. And then these managed resources go, let's say, unnoticed. Or if you have a way to, let's say, signal that this is already available, it's rather, not straightforward. So either you can put a label on the GitHub ticket, or you can write a memo somewhere that I changed this managed resource, and then you go on holiday and nobody remembers who did what. So that's the reason why this pull request came up. So we wanted a way to show in the shoot. For now, we had this pull request only concerns shoots. So we want to show the managed resources that belong to a shoot, which ones are ignored. Now, for my demo, it's rather easy, right? So here above, I have the control plane of my shoot where I have the managed resources. So we can see them here just running and being happy. And then here below, I'm demo. 2 seconds. Here, constraints. We can see the shoot currently and its state, the constraints that it has. Yeah, everything is healthy and it doesn't mention any managed resource. So now what we do is, let's just take the annotation and let's just annotate such a managed resource. Let's say we'll take this. Okay, oh, sorry, I forgot the annotation. So again, get managed. No, wait. Okay. Okay, so we annotated that managed resources, and soon-ish the conditions should show up in the status constraint. It takes a while. Okay, let's wait a bit. Okay, that was correctly annotated, fine. Maybe I should trigger a reconciliation and get it. No. Okay. Okay, now it picked it up. So it took a bit of time. So now we see the new constraint showing up. So some managed resources have been annotated, and here you see which one was it. And this then will also pop up in the shoot UI with a red chiplet stating the same. And again, if we just remove the annotation, again, it will take a bit of time until it will pop up in the constraints. So we could wait for that a bit, or we could conclude that that's the demo, and this is the topic I wanted to present. Just FYI, we have also another pull request that we want to work on to also add this logic for the seed and the garden resource. This is still work in progress. So that was the demo. I think this still needs time. Okay, but it will disappear. Okay, done.
Cool. Thanks, Andrea. Any questions to this topic? If not, next up is Lucas with the NFTables mode support and Calico extension.
Thanks, Raphael. So, hi everyone. Today I'm presenting a topic we worked on some time ago, which was just released 2 weeks ago. So with the support now for NFTables and kubeproxy, since I think some time ago, we wanted to run the Calico mode or the Calico rules also in NFTables mode, which is supported, I think, since 3.29 in Calico. So this pull request or this change does the following: that if kubeproxy is running in NFTables mode, we also propagate that through to Calico so that we run Calico also in NFTables mode. And I can show you how this looks like in your clusters if you are running NFTables. I highly recommend it. We are using it a lot already. So I will show you how a shoot looks like with the full NFTables mode from Calico. So if I flush all the iptables rules, we can see that there is basically nothing. There's something from kubelet, but it's rather empty. And if we now take a look at the rule set of NFTables, we can see that Calico provides all of the filters and chains through NFTables now. So you will see everything in the NFTables changed. For example, how that worked before, this is now a cluster that is not yet running the new Calico extension version. So if we do a iptables flush here, we can see that there is a lot of iptables rules from Calico, but we can also see if we check the rules for rule set, that you can see them here sort of in the NFTables rules as well, but this is the NFTables, I think, compatibility mode. So you can see actually the iptables chains in NFTables, but as you can see here, it's managed by iptables NFT, so it's not
I think we lost him. Let's wait for a second. Maybe he will come back. But yeah, I guess the majority of the topic was explained, luckily.
Maybe an iptables rule.
Exactly. Accidentally blocked the traffic of Teams. Okay. Okay, then I would suggest that we continue for now with the Gardener landscape topic presented by Tim. And in case Lucas comes back and wants to wrap something up, we can do it in the end. So then, Tim, please get started.
Yes, thank you, Raphael, and hello, everyone. Oh, he's coming back. Okay. I'll continue with the topic, or do you want to switch?
Let's ask him. Lucas, are you back?
I think so. I haven't even seen that I was gone. How long did it take? What did you hear? What did you hear?
We saw the compatibility mode and the rules there.
Okay. Yeah, I just wanted to say that there is, I don't need to do the screen sharing again. So there is a mode in Calico that enables you to do a seamless switch. So if you're running your clusters now with iptables, kubeproxy, and switch to NFTables, the old rules will also get cleaned up so that you don't have any orphaned rules in iptables when you go to the NFTables mode, because that can lead to interesting issues with double the chains in place. So yeah, you can just go with NFTables in your clusters now, and you won't see any differences.
Right. Then, any questions before we really continue with Tim? Nope. Okay, then thanks, Lucas, for presenting. And now finally over to Tim.
All right. Okay, hello again. Okay, so this is about the Gardener Landscape Kit, a project we have started some months ago. So there's gap 49 if you're interested in the motivation and more details. So please feel free to check that one out. But this one is more like a practical hands-on in the next 10 minutes. So the best way to explore what the landscape kit is to do it together. Yeah, I just wanted to show you that it's of course a repository in our Gardener organization where all the development happens, and it is still under high development, I would say, so in a intense development phase. So in case you want to try it out, please expect incompatible changes and changes overall. Okay, but let's see what this kit can already do for you and how we envision it to be set up. So the Garden Landscape Kit, if you want to know it in a sentence, or if you will, is a toolkit that helps you to bootstrap and to maintain gardener landscapes. So we put a lot of automation in our gardener controllers and extension controllers. And the toolkit here is gardener's answer to close, you can say, the last mile to get to your landscape. So it's a kind of simplification and maintenance tool. So what you see here is just like a temporary directory that I created for the purpose of this demo. I have the Gardener Landscape Kit binary inside and a configuration. So what we can explore together is here are commands that are available with the Gardener Landscape Kit, and there are two I want to highlight. So the first one is the generate command. That, as it already says, it helps you to generate the landscape eventually and to update it as well. And the other subcommand I'd like to highlight is the resolve command. So the Gardener Landscape Kit is not only able to bootstrap new landscapes, but it is also capable of resolving versions. So the versions come, for example, from an OCM component descriptor, and yeah, it is able to understand this API and to translate it to a structure that is then understood by the Gardener Landscape Kit. So OCM can serve as a version and component input for the Gardener Landscape Kit. But this is optional. And for this demo, I'd actually like to concentrate on the generate command because this is yeah, the most important one. So let's see what it can do here. So we have another subcommands here. We have one that is called base and the other one that is called landscape. The base subcommand of generate lets you generate the base of a landscape. So that means it contains shared resources and configuration. Usually people have more than one landscape. And yeah, the base is pretty similar than something you already know from Customize. It is just yeah, an approach how to bundle and bundle the configuration that you have in place for all the landscapes. And in the landscape, then you have the concrete configuration that is specific to that landscape. That can be additional options, or it can also be options that override the ones in the base. So if you're familiar with Customize, it is exactly that concept. Okay, so I would say in the next step, we're going to generate a base. So let's do that. We have a component configuration, and we need to give it a directory where we want to have the component, the generation to happen. So let's look at the component config for a while. So this is what you probably already know. This is like the Kubernetes configuration style or Kubernetes API definition. We have repositories here, the most important one. And for the base, we need a target. And the target is relative to the target directory that we specify here. So that means if we execute this command, so it happened successfully, we will have a base directory that was created. And inside this base directory, we see a GL key, a Ghana Landscape Kit system folder that is not of so much interest for now. More important is the components directory, because the components directory contains everything that is necessary and relevant to the landscapes. So in this case, we have everything inside that is popular in the community. We of course have Gardener with the operator. We have a garden resource. We have some kind of virtual access to the garden cluster. We have all the Gardener extensions that are known in the community, right? So the AWS extension, also the provider extensions in general. We have the network extensions and so on and so forth. So everything inside here. Maybe we can check out one. There's the extension object that you already know. And yeah, this is very similar to all the other extensions as well that you can find here. So this is the main structure, I would say, underneath components. And if we look a little bit closer, I already said there is this is the garden object, or the object definition that comes from the Gardener. And then next to it, we have a customization. So this is an opinionated approach by the Ghana Landscape Kit because it heavily relies on customize as one technique, how to the overrides and how to manage the resources actually. So this is the first technology I'd like to highlight, and the second technology I'd like to highlight is that the Ghana Landscape Kit relies on Flux as the underlying deployment system. So when you use the Ghana Landscape Kit, it is expecting you to use Flux to get all the resources into the target clusters. And we will see that in the next step. So we have the base right now. Let's go ahead and create the landscape. So this is as simple as replacing base with landscape. But then we need to also look at the configuration again, because now we have the repository landscape. Let's activate this one. Okay, so in this case, we are going to create the landscape directory. This one is needed for Flux. So it's the information for the Flux configuration that it needs so that it has a reference to a Git repository. We need a reference to our base directory, and we need as well a directory where all the landscape assets are generated to. So also this one is relative to the target directory that we specify here. One important note is that even though it's called repositories, it doesn't have to be a Git repository. So you don't need to have a base Git repository and a landscape repository. You can also do that in a mono repo style, as we do it in this demo. So you can generate everything together in one Git repository, if you will. So let's check that one out. Maybe there's. Let me check the.
You haven't saved.
Thank you. That was very important. You rescued me. Thank you very much. Okay, now it worked. So the Ghana Landscape Kit noticed that you're executing the landscape generate sub command for the first time, and then it also tells you some next steps, and the next steps are important to get your Flux cluster up and running. So you would usually follow those ones that are listed here. But let's have a look at the landscape directory. So again, we have a Ghana Landscape Kit system directory, and we have the components here. The components look very similar, at least the structure. It looks exactly the same that we found in that we explored in the base. But this time, of course, we have a customization, and the resources point, or at least one resource in this case, point to the base. So that means that the resource that we can find here overrides the resource in the base directory. And in addition to that, we have some other resources that are usually very specific to the landscape, because there are some infrastructure credentials involved here, and you certainly don't want to share infrastructure credentials between various landscapes. So also kind of opinionated here, of course, but more or less the Gartner best practice, if you will. Okay, so this is what happens here, and the same is true for all the extensions. So you will find the overrides here for the base again. So it's pretty similar, and also very simple. If you're already familiar with Customize, I think it's very clear what is happening here. Yes, and then another part and important point to notice is that you can, of course, do any customization here. So that means if we change something here in our garden resource, let's put IPv6 here as well, and we generate the landscape again, then this will not be overwritten. So the Gartner Landscape Kit retains your own customizations that are important to your landscapes. Everything that is added in addition, that was changed, any comments whatsoever. So this is also important, of course, so that you can do your configuration that you need to do. All right. Another point when you talk about customizations is that you are also able to add custom components here. So the Gartner Landscape Kit comes with a fixed set of components. We saw the Gartner core components. We saw some well-known extensions. But in case you have some custom extensions that are maybe also private, and can't make it to the Gartner Landscape Kit upstream, you still have the option to add another directory here. Of course, you need also, or you should also do it in the base. Add your component here, and then the Gartner Landscape Kit will respect that. It will more or less don't touch it when you generate something. It will stay as is. However, it will help you to generate the versions, or to resolve the versions that might be inside such custom components. So let's imagine you have an OCM component descriptor that has a custom component or a custom extension inside with some version, and so on and so forth. Then the Gartner Landscape Kit will help you to translate that version information from that component descriptor into your custom extension. So this is a more complex use case, but as I said, so you're free to add your own stuff there, and it is not limited to the ones that come with the Gartner Landscape Kit out of the box. Okay, so this is the general overview, at least when it comes to generation of a landscape kit, and we did that now initially. So this is something how you would usually get started. But as I said in the beginning, the Gartner Landscape Kit does not only help you to bootstrap something or adopt an existing landscape, it also helps you to maintain it on a regular basis. So we also have the day 2 approach implemented as well. But of course, you would never execute a Gartner Landscape Kit on some kind of development or operator machine on a daily basis or on a regular basis. So in the second part of the demo, I'd like to show how we envision that. So we have a Frojo instance here. So it's it comes from our local setup from the Gartner Landscape Kit, and please bear with us that we haven't set up any GitHub Enterprise for the local setup. So this is our Git service here, which is totally sufficient for this purpose. Okay, what do we have here? So this is more like a realistic scenario. We have the base repository and we have the landscape repository. It's called test landscape. Just let us dive in a little bit. So in this case, we don't have a mono repo style. So we have base being a Git submodule. So this is another way how you could structure it, how to include the base into a landscape repository. Okay, let's jump to the base again. And let's say we have that already in place. So we bootstrapped the landscape, or we adopted it. We initially did every step that was necessary on a development or on a local machine. Uploaded everything into the Git repositories. And now we want to do some changes. So how do we go from there? Wrong file. Let's go into the configuration again. And this case, we only included certain components. So, but we're missing the other ones. So we won't find any components directory here because we excluded everything else. So let's change that. We can just remove that from the configuration, which means we are activating all the components that are inside the Gardener Landscape Kit. We change it. We usually create another pull request for this one. Okay, let's open the pull request. Okay, and then another action starts. So, and the action is also something that we deliver with the Gardener Landscape Kit, and it enables you to execute the Landscape Kit in the scope of a GitHub workflow, or in this case, I mean, Rotor is also compatible with that style. So with some workload engine around it, and we use GitHub as the de facto standard for this. Also opinionated again, but probably will cover 90% of all use cases. So let's check it. Okay, it was executed successfully, and we instructed, we can go there for a second. So, and we instructed the Gardener Landscape Kit to call generate again. So in this case, it's the base directory. So it executed generate base. And everything that has changed with generate base, so the output was added to the pull request again. So we see, this was our tiny change, and then generate base ran, and the output was added to the pull request, which of course we activated all the components in one step, and you will find the addition of all the components in the very same pull request. So that means we envision the Landscape Kit to be your assistant. So every change that you do in a pull request, the generation happens again, and any adjustments also happens in the very same scope. So you would normally go over this commit and check if everything is reasonable and the way it should be. So we should double check that, of course. But let's say we're merging this one. Okay. And now we have all the components in the repository. So this is how we envision the Landscape Kit to be executed in a day 2 operation, if you will. Okay, and I'd like to show you or give you some outlook what we're working on at the moment, because we just activated the components, but we also want the Gardener Landscape Kit to deliver some migration logic. So what we will do is we will upgrade the Gardener version. So for the purpose of this demo, I'm taking a shortcut here. Let's say we are upgrading or updating to this Gardener version. And let's imagine this Gardener version has some incompatible change in an API, which of course will never happen, but let's imagine it would. At least we would need to have some adjustments to the resources that are checked in the base repository. Okay, update Gardener. Committed. Oh, sorry. Oh, that was my fault. Okay, I did it wrongly. That was my fault. I just wanted to open another pull request. Okay, that was very dumb from my side. Sorry about that. Let's revert that. Let's revert it very quickly and do it again. Okay, we're filing a new pull request. Then the action runs again. So it's the very same command, generate base, but with the changes that we introduced. So with just the Gardener update. Let's see. We have another commit. Okay, and we see in this commit, it is, it implemented, or the output of this generate base contains the incompatible change that was introduced with this Gardener version. So, and now we have the option with the Gardener Landscape Kit to roll out such changes. I mean, this is of course fabricated, but it can be any kind of migration steps that are necessary to go from one version, be it Gardener or extension, to the other one. Right? So usually it could be some API changes, but it can also think of cleanup jobs that are added on top, and then will run on the landscapes. Can be anything. So this is what we're currently working on to give some kind of version and migration context to the components that are in the landscape kit. And this is the last thing I'd like to mention in the session. So this is what you've just seen. So that this is the version and migration context for components that we are working on. Then we're working on that the Gardener Landscape Kit enables you to generate gardenlet and manage seed resources, which it can do today. So if you use the Gardener Landscape Kit to bootstrap your landscape, you still have to create the gardenlet and manage resources yourself. And the last point, very interesting for the community, I think, is that we are working on a qualified image vector, which means that we are extracting the components and the versions that we're running on a landscape and that were qualified on a landscape, meaning some very extensive tests ran on the landscapes. We collect all that information and contribute it back to the Gardener Landscape Kit repository, so that everyone in the community can be really certain that this version combination and of components really works if they are deployed together. Okay, I think I took more than 10 minutes. Sorry for that, but hope that it was okay. All right, that's it from my side. Thanks.
There are a few questions in the chat. Maybe you want to take a look and answer them.
Let me check where to start. This is Garden Linux. This was from Lucas. Okay. Okay, so there was this question, if we already use Helm chart with OCM-based image vector override approach and it works smoothly, what are the benefits to switch to landscape setup? Landscape setup in this case? Okay, so if you're, I think if you already set up something similar, then of course, then the benefit I would highlight in this case is what I've just shown, because the Gardener Landscape Kit will also be capable of delivering migration actions that come from the maintainers. So the action I just showed, right? So changing the API from a certain version to the other one would normally be implemented by the Gardener maintainers in the Landscape Kit. So it is once implemented there and then roll out to every landscape where this is relevant. Okay, so there was another question. If there are multiple Gardener landscape, would it be possible to manage Gardener version outside of the base in the landscape override. Yes, it is possible. So this is a small feature we're working on at the moment. I'm not sure if the pull request is already open, but you can pin the Gardener version for certain landscapes as well, yes.
All right. Any final questions for the Gardener Landscape Kit? Nope. Cool. Then thanks, Tim, for presenting. Thanks, everybody, for joining. This will be the end of today, and we meet again in 2 weeks for the next occurrence. Have a nice time. Bye-bye.
See you. Bye-bye. Thank you very much.
Bye.
Bye.
Bye.